This is trial number 2 of graphing a cosine with everything on it. The last attempt was beautiful. It turned out great. Now I'm not going to show it to you because it'll just frustrate me more, but my program still didn't work, so I'm going to try to break this up again more often. So that'll be why it's a little choppy probably. So what we're doing here is we want to graph a cosine. This time we're going to actually include everything. So we're going to include phase shifts, vertical shifts, everything. Whereas the first couple videos about sine were just by themselves. There was no shifts at all. So what we want to do first is we want to actually start graphing this using the graphing manifesto, which I've kept over here for a reference. And then at the end we'll actually check ourselves on the TI-83. So getting started here, looking first at the artistry section, we've got to check our shape. So cosine, it always starts at the maximum or the minimum. And if we think about the reflection here, since this is a positive 3 in front, it's a positive cosine. Positive cosine graphs look like this. They start at the top, come back down, like so. And so that's what we're going to do first. I'm going to actually go up here, and I'm going to start at the top and graph the cosine. And there we go. We've graphed our cosine graph. This is like our blank one. We're ready to ascribe the correct pieces to it, the correct labels, to make it clear that this is the correct cosine graph that we're looking for. So there we go. First step done. Artistry's out of the way. Okay, second, we've got to look at the labelry. And so I'm going to start with the most important piece, the period. So my period, as we talked about last time, is going to be 2 pi divided by the cosine, or the coefficient of the x itself. So here's our x, there's nothing in front, so that's just a 1. So my period is 2 pi over 1, which equals 2 pi. And while we're at it, my half period, just so I keep that there, is going to be half of 2 pi, which is just pi. So nothing bad. Again, we're not going to label it yet because we have a phase shift, a starting point this time, so we'll need to pay attention to that. But before I get to the shifts, let's do the other thing that we're familiar with, and that's the amplitude. So my amplitude is going to be the absolute value of the number in front of the actual trig function. So absolute value of 3 is 3 itself. So we've got those two pieces ready. Okay, so now we actually have to get on to the shifts. So for the shifts, I'm going to go ahead and use red. So first off, to find my phase shift or starting point, I'm going to do that by setting the argument equal to 0, seeing what makes the argument equal to 0, because that'll kind of center our function, figure out where it's centered at. And so in this case, it's kind of easy, it'll be pi, but since normally we have to solve it, I will do that. So we'll have x equals pi as my phase shift, and so I'm going to go ahead and label that right here. So there's x equals pi. And now, before we do the actual figuring out the boundaries on the outside here, let's actually find the vertical shift, and that's actually a lot quicker than this. Vertical shift's just whatever constant we're adding to the function. So here's our function. We're shifting it by +2, so my vertical shift is +2, or up 2. So I can label this y equals +2. And so there we go. We've kind of set everything up. We've just got to now be real specific and label the extremes on each of these axes. So labeling these things to finish off this graph, make sure we've got the right cosine. What we need to do is we need to figure out what these points are first, and then as we go through, hopefully we'll be able to redraw the x and y axes if they show up in our picture, and we'll be able to get all the extremes of the function. So first I'm going to do the slightly easier version, and that comes from here, figuring out the labels on the y-axis. So those will come because the amplitude is the distance from or half the distance from the max to the min. So it's half that distance, which means it's 3 units between the vertical shift line and the actual maximum. So in this case, if I want to find like the max, I can find that by taking my vertical shift of +2 and adding my amplitude, which is 3, giving me a maximum value of 5. Again, this will be real important if we're actually analyzing the range of the function. For the minimum, I'll take the same 2 ingredients. It'll be 2 for the vertical shift, minus 3 for the amplitude, which will be -1. So that means right here, that's -1. And thankfully, that actually tells me where the x-axis actually is in this picture. I mean, it won't be precise, but it'll be somewhere around here. So since it's actually in the picture, I'm going to go ahead and draw it in. So this is the x-axis. So normally it would be centered here. So our graph's been moved up, which makes sense because it's a vertical shift of +2, so it went up. Okay, so now to find the other two, we need to use the period and the phase shift. So for the right end, I'm going to find that by taking my phase shift of pi and adding a period. So pi plus 2 pi is 3 pi. So that guy will be right here. And then for my left end, again, these terms I just completely made up right now. They're nothing technical. But to find that, I'll take my phase shift of pi and then subtract a period and get negative pi. So all the way over here is negative pi. Now it's good form for right now to also get the half period in there, so we have a little bit of an idea of where everything else is spaced at. So to find that, my half period I said was pi. So for my half ends, I'm going to get pi plus pi, which is 2 pi. So that guy will be right here, obviously. And then the other one will be pi minus pi, which is really convenient. And I didn't actually plan this, but it is nice. That's actually going to be right here. So this will be at 0, which means that this is our y-axis. So this is actually pretty cool. We actually now know that our y-axis is sitting right there in front of us. So now, at this point, putting aside the fact that we might add some other analytic tools later, we've actually graphed our function. So at this point, all we want to do now is actually see if we graphed it correctly. So this is where it gets kind of fun. You get to see how cool and how well you actually did. So I'm going to use Magical Gigantic TI-83. So here it is. Got it sitting right there. Let me pull this off to the side. Yeah, look at that. Pretty cool. So here we go. I'm going to turn it on. The memory's been cleared. That's nice. Now what I want to do is I want to actually graph this function. So I'm going to go ahead and type that in. It's a little awkward because I have to reach with this mouse and do it. But this will be 3 cosine x minus pi. I'm sorry you can't see all the buttons, but it's better that way. Plus 2. So there's my function. So now I'd be ready to graph it, but I want to first make sure I have the right mode and that my window's set. So my mode, I want it to be in radian mode, because notice we're using pi's. This is a radian mode graph. So that's cool. Now I want to look at my window. So here we go. So for my window, I want it to mimic exactly what I see here. So on the x-axis, I want to go from negative pi to 3 pi, to my right and left ends. So to do that, let me punch it in. Negative pi, all the way to 3 pi. And then for my scale, it doesn't really matter, but I'm going to go ahead and put pi as my scale, just because you can kind of see our graphs are apart. We got negative pi, 0, negative pi, 0, pi, 2 pi, 3 pi. So it's kind of spaced that way on our graph. Then for the y min and y max, we've got to look down here and go, okay, I'm going from negative 1 to 5. So I'll do that on here as well. Negative 1 to 5. And hopefully this time, with my window set, hopefully this looks good, and I can contain my excitement, because this always makes me really, really giddy. So here we go. That looks pretty good. Like, what really, really impresses me is, if you notice right here, we've got our x-axis and our y-axis, and then on the graph right here, got our x-axis and our y-axis. So it actually mimics the shape that we see over here. So I submit that we actually did a pretty awesome job on this one. So hopefully, as you did this or followed along, you got a similar result, and hopefully this video has been useful to you. So